Everyone, it's Mrs. Woodruff again. Today we're going to start a new unit. We're going to head into geometry, and this unit is going to be about volume. Before we get to the volume that is the 8th grade piece, I'd like to spend today to review some of our 7th grade ideas. So today we're going to do a volume refresher. In 7th grade, there were two categories of shapes that we found the volume of. One was prisms and one was pyramids. I want you to look at the shapes on the slide, and just before I talk about it, do you remember the difference between a prism and a pyramid? I like to say that the prisms are very boxy shapes, so obviously something like this or this looks like a box, or this one. But the shape here, here, and here are also prisms. A prism is defined by having two bases, two sides that are the exact same shape. So the one I'm pointing to right here, there is a green octagon, and if you look through the shape, you can see kind of a dark maroon octagon on the other end. There are two congruent, same shape, same size bases, and then the sides that join them, that are called lateral sides, are all rectangles. So in this particular octagonal prism, there are two octagons and 8 rectangles that would make up that shape. Our most basic prism is a rectangular prism that is the box that we're familiar with. So the pink one, this green one, and the red one are all rectangular prisms, this one being more special in that his 6 sides are all the same, so he's called a cube, but he's still a rectangular prism. If we look at the pink one, there's kind of a darker pink rectangle here, and we can imagine that the bottom is the same shape, same size. And then there are 4 side rectangles as well. Let's just take a look at this particular prism, which is a triangular prism. It has a red triangular base, and on the other end also a triangular base, and on the sides are 3 rectangle sides. So prisms are boxy. They have 2 bases that are identical shapes on either end, and they're joined by rectangles. The second shape that's on the slide is called a pyramid. A pyramid has a single base. It has one shape, and then the sides, instead of being rectangles, are all triangles, and they kind of join in a point at the top. That's called a pyramid. So here's kind of a picture of what we've just talked about, where we can see prisms up here. This is called you can see it's a pentagon, it's a pentagonal prism, a rectangular prism, and then of course the special rectangular prism is a cube where all 6 sides are the same and are squares. This one over here is a triangular prism. This is a square-based prism, and then we have a pentagonal prism down here as well. Here are our pyramids. Single base coming up to a point, and these are the shapes that we're heading for in 8th grade. I call them our circular volumes, so our cylinder, our cone, and our sphere, and we'll be talking more about those in a few lessons. Just to remind you of some vocabulary, when you have a shape on the side, that's called a face. So this triangular prism has 2 triangle faces, one on the top, one on the bottom, and it has 3 rectangle faces, one that we can see, and the other 2 are kind of behind the shape. So the faces would be the shapes that make up the side. If there was a box, it would be the shapes that are making up the cardboard sides. Where 2 of those faces come together is called an edge. If you think of the mobiles hanging in my room, the straws are the edges that make up the shape. So if we look at this rectangular prism here, it would have 4 edges on the top, 4 edges on the bottom, and then 4 little edges that have to join them. It would have 12 edges altogether. The last word that we need to be remembering today is when 2 edges come together in that sharp point is called a vertex. The plural of vertex is vertices. So if we look at this pentagonal prism, you can see that there are 5 vertices on this top pentagon, and there are 5 on the bottom. There would be 10 sharp corner points called vertices on that 3D shape. Now, before we do our review of volume, let's just remember what we mean by 3D, dimensions. So when we measured our height in class a few months back, we talked about a length, and a length is measured in a single unit. So when you measured yourself, you were 140 centimeters. You weren't centimeters squared or centimeters cubed. So one dimension would be a length, and it has a singular unit. So here is that singular dimension, but when we go up and down as well as left and right, we've added a second dimension. 2 dimensions are measured by area, and our unit on area would be an exponent of 2, and I like to say area square area. We're going to punch that out. We're going to add a third dimension, so we're not only going left and right and up and down, but we're also kind of going back and forward. So there's 3 dimensions, and that's volume. And our units, when we calculate volume, are going to have that exponent of 3 to represent those 3 dimensions: length, width, and height. Volume represents how many cubic units can fit into a shape. So if we're talking about centimeters, how many little centimeters that would fit in here that are cubes that are a centimeter by a centimeter by a centimeter. To show you that picture, let me go on to the next slide here, and you'll kind of see what I mean down here. So if we were to fill a shape with cubic units, so in this case cubic centimeters, 1 centimeter by 1 centimeter by 1 centimeter, how many of those cubes would fit in the box? And that number is called volume. To calculate volume of a rectangular prism of a box, you take the area of the base of the bottom, which is length times width, and then multiply it by how high that box is. So length times width times height. The base area, which is denoted in math by a capital B, is the length times the width, and then we measure it by that third dimension, height, to get the volume. So you'll see length times width times height, or we could write that formula that B would take over the length times width because that's the area of the base. Every rectangular prism, no matter what its base, you can find its volume by taking the area of the base times how tall, the height of the prism. So it doesn't have to be a rectangle. It could be a triangle, or it could be a hexagon. Whatever the shape is, you've got to find the area of that base and multiply it by the height. Now, when you have a triangle, you're going to have to take the base of the triangle, the height of the triangle, so base times height, and take 1/2. So remember that the area of a triangle is half the base times the height of the triangle. Once you get that single area of the triangle, you're going to have to multiply it by how tall the prism is. So it's the base area times the height. We're going to do one of those in just a second. I put this one on here as well because the 7th grade book, which is what I'm getting these pages from, didn't have this. So I just wanted to talk about what if it wasn't a triangle, what if it wasn't a rectangle. In your mathematical career, you do not know how to find the base area, or excuse me, the area of a hexagon. So I would have to give that to you. So basically I'm telling you right here that the area of this hexagon is 28.5 millimeters squared. Now this prism has fallen over, it's laying down, so the height of the prism is the 8.1. Think of yourself when you're laying in your bed, your height would kind of go along the bed. So you would take the base area, which I gave to you, multiply by 8.1 in your calculator, and the volume of this hexagonal prism would be 230.9 millimeters cubed. Don't forget that power of 3 for volume. Don't confuse the height of the prism with the height of the triangle. Just wanted to point that out. I'm going to show you what I mean in the next couple examples here. All right, so let's do these two together, and then I'll give you a chance to see if you remember. The volume of a rectangular prism is pretty easy. We take the area of the base, which in this case, length times width, 11 times 5, and multiply it by the height. And if we take 11 times 5, that's the base area, times the height of the prism, we would get 220. And don't forget that your inches have to have an exponent of 3. We have an inch times an inch times an inch, and that's why there's 3 powers of inches there. Okay, let's talk about this one because we didn't get to see that on the last page. How do you find the volume of a triangular prism? So here is the base, see the triangle, and there's a matching base on the other end. I need to find the area of this triangle and multiply it by the height of the prism. Now the prism's laying down, so there's its height, but I need to work with this triangle first. So I'm going to take base times height, 7 times 3. See the right angle? Your height always has to make a right angle with your base, right? So there is your base times height, 21, but don't forget that you only need half of that because it's a triangle. Easy way to do that in the calculator is to multiply by 0.5. So I'm going to take 7 times 3 times 0.5, and that will give me the area of one triangle. Multiply by the height of the prism, and I get the volume of the triangular prism. So just to show you this again, 0.5 times 3 times 7, that's the area of this triangle. Multiply it by the height, and that's the volume of the prism. Don't forget your third unit here. Sometimes you can have comparison problems where you find the volume of one thing and compare it to the volume of another. If we're talking about like a cabinet in your kitchen, it would look this shape. It would be a rectangular prism. So you would just take the length times the width times the height, and the same thing with the second cabinet. You'd find their volumes and then you could compare them. It's just asking who is greater here. So if we just look, the bigger number, cabinet 2, would hold more. It would hold more cubic feet. Let me just undo these so you can just see that here are the answers that were in the book. And that's the end of the instruction on prism. So what I'm going to have you do now is try 3 on your own. So pause the video and see if you can find the volume of this rectangular prism, this triangular prism, and this pentagonal prism, and you've got to pay attention what's down here for this one. Once you're done, unpause the video. Let's see how you did. Okay, the first one, the blue one's the easiest. Rectangular prism, length times width times height. And don't forget your units. It would be 72 meters. And do not forget that volume is measured in cubic units. So we need a 3 there. Length times width times height. 3 dimensions. The pentagon is actually the next easiest. Even though we can't find the area of a pentagon, I gave it to you. So one pentagon here has an area of 24 meters squared. That's the base area, the capital B. Multiply it by the height, and you've got the volume, 72 meters. Don't forget the 3 for cubed units. The triangle is usually the toughest one because you have a little bit of work to do on that base. So right here, I'm going to take the base of the triangle times the height. So the height makes a right angle with the base. I don't have this number right here, but if I just look down here, you'll notice if this is 7.5, this has to be 7.5. So 8 times 7.5, and don't forget that you need half for a triangle. So we're going to multiply that by 0.5. So if you look right here, that's what we just talked about, and that's the base area. We still have to multiply it by the height of the prism to get the stack, to get the third dimension. And when you multiply these all together, you get 105, and don't forget it's inches cubed. The other shape that we worked with in 7th grade was a pyramid. And a pyramid, again, has a single base. So we're going to see that base area again. We're still going to multiply it by the height. But notice that some of the volume is missing because it comes into a point. So we divide it by 3. The volume of a pyramid is only a third of the volume of a prism that had the same dimensions. So we're going to take the base area times the height of the pyramid, and we're going to divide it by 3. Your book likes to do this multiply by 1/3. Multiplying by 1/3 is the same thing as dividing by 3. It's easier in the calculator to think of it this way. Again, This was in the 7th grade book. I'm just going to skip down to this example, and you're going to see a rectangular based pyramid. So the base area would be the 3.2 times the 1.4. You see it in red right here. I'm going to multiply that by the height of the pyramid, and then I'm going to divide it by 3. And you're going to notice the approximation symbol, the wiggly equals here, because they're asking you to round to the 10th, so they only want 1 decimal. And it is 4.2. And notice right down here they wrote cubic inches instead of putting the inches with the power of 3. Well, what happens if that base is a triangle? Well, we have to find the area of the base. So it would be the base times the height of the triangle in the bottom. So 8.1 times 6.4, but don't forget to take half. The easiest way to do that in the calculator is to multiply by 0.5. So if you take 0.5 times 8.1 times 6.4, that's the area of the triangle. You got to multiply it by the height of the pyramid, which is running through the center. You see this dotted line because you can't see that. It's hiding in the middle of the shape, and that's what they're trying to show you with the dotted line. So you multiply it by 11, and then don't forget to divide by 3. Same thing as multiplying by a third. Divide by 3 to get the volume of the pyramid. And again, notice they're putting the units down here. This point in time, I don't have a triangular one here. I'll have one on the worksheet, but see if you can do these 2 pyramids and come back and we'll see how you did. Okay, let's see how you did over here. The base would be 23 times 14. It's not a triangle, so you don't have to worry about anything else, just 23 times 14. We're going to multiply it by the height. And if we stop there, that would be a prism, but it's not a prism. So we need to divide it by 3 to get your volume. Did you get 2,683.3 yards cubed? We've got another rectangular based pyramid over here. So we're going to take the base area of 1.8 times 2.2, multiply it by the height. If you stopped there, it would be the volume of a prism. This isn't a prism. So we need to divide it by 3 to get the pyramid area. And did you get about 3.8 centimeters cubed? Remember your units. You remember that those units are cubed for volume. Well, I hope this was a good refresher on the volumes that we covered in 7th grade. There is a worksheet for you to practice. That's it for today. Have a great day, everybody.